Okay, example 4 here where we prove that two triangles are congruent. It's kind of already done for us. I don't know why it's written as an example and not as a learning segment, but let's just go through and see why this all works out. So they want us to write a two-column proof. A two-column proof requires some statements and some reasons for making those statements. So what is given to us? Well, given to us is angle J is congruent to angle P. So this guy and this guy are congruent. The length JK is congruent to the length PM. So JK, that line segment, is congruent to PM. Okay, we're going to mark that with one dashed line. Since they're both marked with one dashed line, that means they are congruent. Okay, line segment JL is congruent to line segment PL. So J to L and P to L each get marked with two lines. Okay, the 1 and the 2 is just to separate them from each other. So we could have marked these guys with two lines and these guys with one line. Wouldn't have made any difference. It's just saying that this is the same as that and this is the same as that. Okay, and L bisects KM. So L is right in the middle of K to M. Okay, now prove that triangle JLK is congruent to triangle PLM. Well, to prove that, basically we need to prove that the remaining angles, M and K, are the same. We need to prove that angles inside here are the same, and we need to prove that these side lengths are the same, right? We need to prove that all of the sides are congruent and all of the angles are congruent. Okay, so these are all our given statements. Now we can also make additional statements. We can say that JLK, the angle JLK, which was this guy, is congruent to PLM, this guy. These two are congruent because vertical angles are always congruent. Vertical angles are like when we cross two straight lines, the ones on opposite sides from each other are given that vocabulary term, vertical angles. And that's just sort of a known feature that vertical angles are always congruent. You always have the same value on opposite sides. So these two little ones are the same, and these two big ones are also the same as each other. Okay, these large angles on the outside of the shape. LK is approximately equal to LM, or is, sorry, congruent to LM. LK is congruent to LM. Well, we know that's true because that's just the definition of a bisector. A bisector is something that cuts it in half. So if you cut things in half, those two pieces are the same. You just have one half and you have the other half. Okay. The third angles theorem would tell us that angle K and angle M are the same. K and M are the same. And we can say that because we've already shown that these little angles are the same. We've been given that these outer angles are the same, which only leaves us our third angle, angle K and angle M, to be the same as well. Therefore, because all of our angles and all of our side lengths have congruent partners, that means that those two triangles are themselves congruent triangles. Okay, if you want to take a moment, you could pause the video and you could go through those same kind of steps to try to write a paragraph proof for why these two triangles are congruent. If not, you could just move on to the next example with me, example number 5, which I believe might be our final one.